Hello everyone. Esri have invited me along today to talk you through the journey NHS Fife have been on in order to map our estate to better manage our green spaces. So just for a bit of background on us, NHS Fife are one of 14 territorial health boards in Scotland and provide healthcare to around 370,000 people across Fife. We have 45 main sites, which includes 10 main hospitals, medical practices, midwifery units, community clinics and dental health centres, which accumulates to an 130-hectare estate. So I'm Catherine Hasty, and I'm one of the sustainability officers within the Health Board, meaning that my job is primarily focused on sustainability management of our buildings and land, which brings me on to why I'm here today, to talk to you about the mapping project which took place last year. So my journey with the Health Board actually started last summer when I completed a 2-month sustainability internship. Within this internship, myself and the other intern Yasmin were given around 6 weeks to complete a project which involved creating a digital map of our estate to find out not only where our green spaces were, but also the types of green spaces that we had. So over the next 15 minutes or so, I'm going to talk you through exactly why we carried out this project in the first place, what we did and exactly how we did it using ArcGIS technology, and finally I'm going to round up by talking you through what we're using this for and the many benefits that it has brought to the board. So just, I guess, to talk through exactly why we carried this out. Why did we do it in the first place? Well, we actually had no centralised record of our green space. So we had absolutely no idea where our green spaces were or the types of green spaces that we had. And without having this kind of accurate record, it was making it really difficult to kind of understand our green spaces and to be able to manage them properly, as well as meet the many sustainability requirements and targets that have been placed on the board. So much of our sustainability agenda is driven by the NHS Scotland Climate Emergency and Sustainability Strategy, which was developed last year and outlines an ambitious approach for NHS Scotland to reduce greenhouse gas emissions, reduce environmental impact, and also adapt to climate change. So one of the key themes within this strategy involved valuing, maintaining, and protecting NHS green space, with one of the key recommended actions being to digitally map your green space to ensure that this public asset is managed in a way that brings a range of health promotional benefits whilst also, increasing biodiversity and also adapting to climate change. We also work with the National Sustainability Assessment Tool, which mandates that all health boards in Scotland assess their sustainability performance across 16 key areas of sustainability, which includes green space and also nature and biodiversity. So bringing this all together, it was really important that we kind of gained a further understanding of our green spaces and the types of green spaces that we had, and we were able to kind of record this all in one place and really visually as well. And this is what mapping of our estate has allowed us to do, and it's allowed us to do it with such great attention to detail that it's already helped us excel in our commitment towards sustainability. So having carried out this project, we actually discovered that a staggering 62% of NHS Fife owned land is classified as green space. Now, I think for me, this was completely shocking for 2 key reasons. The first being that I simply never would have expected that over 50% of the land a health board owns would be classified as outdoor green space estate. And secondly, it was really shocking to me because whilst this was a great discovery, it only kind of highlighted that this wasn't being managed properly, it wasn't being used to its full potential, and that we actually didn't have a plan for it. So that's kind of, again, what I'm going to speak you through today, is how we came to this conclusion and what we are doing now that we have this information. So this project all started with a fellow colleague and sustainability officer, John, reaching out to Esri because he knew that we needed a way that we could capture data really easily, particularly due to the lack of GIS expertise within the team. So John had heard about Esri and about ArcGIS technology and wanted to see if this was something that could work for us. So working with Esri, they came up with a web-only solution which was relatively easy to use. Now, I must say, as one of the people carrying out this project, it was definitely not easy to use, but considerably more simple and intuitive than a desktop solution would have been. So this solution by Esri allowed us to accurately capture all the boundaries of the NHS Fife estate and then accurately categorise our land. So we used Ordnance Survey master map data, which is the most granular level data in the UK, as a starting point for collecting our land use data. So using Suite for ArcGIS, we were able to accurately categorise every single area of NHS Fife land with exact precision. So we first broke this down into man-made land and green space land, and then broke this down into further subcategories such as buildings, car park, grassland, gardens, shrubbery, paths, so on and so forth. We used a total of 60 categorisations throughout our project, and we also broke down some of our categories into subcategories. So, for example, we split grassland into mowed grassland and meadow area. It was really important for us to kind of collect this level of detail, because the way that you would manage mowed grassland versus the way that you would manage meadow is completely different. It supports different biodiversity, and it brings a range of different benefits. So therefore, we really wanted to capture an 100% clear and picture of our estate that would only help us kind of manage and develop our green spaces better in the future. I think it's also really important to mention at this point that one of the other benefits of using ArcGIS Online is that it acted as a single source of truth, in that the web maps that we created in Suite could then be reused in other apps such as ArcGIS Field Maps, Story Maps, and the dashboard as well. So we could reuse all this data over and over again without having to recreate anything, and kind of having everything built into one environment just made life so much easier as we worked through the project. So alongside Suite, we also used ArcGIS Field Maps, and this was because as we were working through our project, we had to make sure that what we captured on Suite was accurate. So we did this through kind of going on site and physically seeing the land, and also using Google Street View and aerial imagery. So ArcGIS Field Maps was a really important part of this quality assurance process, as we were able to collect granular data in the field and kind of take notes and pictures and upload them as we were walking around the sites, and then we could transfer this data onto Suite once we were back at our desks. Also, we were able to update Suite and Field Maps in conjunction with each other, so it meant that our mapping work was always really up to date and accurate. Next up, we created a dashboard, which is publicly available and has been a really useful way of kind of sharing the outputs of our work. So within the dashboard, you can filter data and find really specified information about particular areas. So within this example, this is our main site, Victoria Hospital in Kirkcaldy, and this kind of area highlighted in pink shows that it is woodland. The final step in our project involved sharing our story and kind of getting what we had done out there. And we did this by creating 3 story maps. So the first story map was just a breakdown of land use across the NHS Fife estate. The second one involved green space improvements that had already happened at the Health Board. And then we created a final map, which was green space proposals for future development to take place. So as I kind of mentioned previously, one of the great benefits of using ArcGIS Online is that we could share the data. So we were able to actually, put a dashboard into our story maps alongside other things, which made them really interactive and engaging, and allowed us to share the outputs of our work in a very visual and captivating way. We also hope to continually update our story maps as we work through our green space development, and this is going to be really important for kind of keeping patients, staff, the community, and any other relevant stakeholders really up to date on what's going on with our green estate. This is particularly important for us as a key public sector organisation and a key anchor institution within Fife. So now that I've kind of spoken you through exactly what we did, I'm now going to talk you through what we're actually using this mapping work for and how it has been of such great benefit to the Health Board. So I think the key benefit of having our entire estate mapped is that it's been the foundation for which our 2030 Greenspace Strategy has been developed. So our NHS Fife 2030 Greenspace Strategy aims to deliver a groundbreaking approach to our green space that will help us kind of meet the targets and requirements set out for us by NHS Scotland and the Scottish Government, whilst also allowing us to create spaces that will promote health and well-being of our patients as well. So having detailed GIS mapping of our estate has been really crucial for the preparation of this strategy and is also going to be extremely important for the delivering and monitoring of our progress over the next 7 or so years. So within this, as part of our green space strategy, we really want to work on building up local partnerships and see how we can work with local people in Fife to build green spaces that are going to benefit the whole community. So one such partnership that we are looking at just now is working with Food for Fife, who are hopefully going to use some of our land for community allotments and food growing purposes. So again, like having this detailed map of our estate is only making conversations around projects like these so much easier, as we're able to really easily identify areas of land and then kind of see how we can develop projects around these. We are also looking at how we can use our estate to increase biodiversity and kind of work towards tackling the climate and nature emergencies that we're currently facing. So we're already looking at ways that we can kind of transform rooftops, courtyards, and grassland into areas that will support more diverse ecosystems and wildlife. One of the kind of more relatively simple and budget-friendly projects that we're looking at just now is just transforming mowed grassland into meadow. You don't really have to do very much, and it's just quite easy, but can really bring a lot of increased biodiversity benefits. And again, just having our estate mapped is really allowing us to kind of find these parcels of land and then find the best management solutions for them. Finally, I think it's really important to kind of talk about the health and well-being aspect, and the fact that within NHS Fife, health and well-being of our patients, our staff, and the community will always be our #1 priority. So having a better understanding of our green space is only allowing for us to develop projects that bring a range of health and well-being benefits for our patients, such as through rehabilitation and therapeutic purposes. Alongside this, though, on a more simple note, it's also just allowing us to create beautiful green spaces which bring a range of health and well-being benefits in itself. So one such project that we're looking at just now is at one of our main hospitals and involves creating a garden for rehabilitation purposes and kind of just looking at different aspects, such as having like steps if people are kind of learning how to walk again, and flower beds at different heights for people to work out in their rehab, and also bringing in the kind of wildlife and how we can increase biodiversity within this as well. Here are just some pictures of our lovely green spaces across a few of our sites. And yeah, so just to round up, what I want you to kind of take away from this session today is the journey that we have been on from having literally no understanding of our green space at all to having a fully captured, detailed and accurate account of our green space that's only bringing a multitude of benefits to our board. When we first started this project, we just wanted to gain a bit more of an understanding of where our green spaces were and what kinds of green spaces we had, and also just help us kind of move in the right direction towards the many sustainability targets and requirements that have been placed on the board. But what we never could have anticipated is the range of other benefits that this work is having and will bring in the future as well. What I really hope I've managed to show you is how a relatively small 2-month internship project carried out by individuals with quite limited GIS expertise has actually transpired into us fully capturing our estate to such a high degree of accuracy and detail that it actually was the foundation for which our Greenspace strategy was developed and has already been crucial to the development of many health-enhancing green space projects across the organisation. I truly believe that this work is going to bring a brighter future for NHS Fife, for our staff, for our patients, for the wider community, and of course for the environment too. Thank you very much for listening. I'll be around all day, so if anyone has any questions, please feel free to come up and speak to me, and if not, please feel free to send me an email. Thank you.
So thank you very much for that excellent presentation, Catherine. Good morning, everyone. My name is Daniel Graveling, and I'm a GIS consultant for Esri UK. For the next 20 minutes or so, my colleague Amy Luscombe and I are going to demonstrate to you an integrated workflow using a suite for ArcGIS configuration similar to one used by NHS Fife, as well as ArcGIS field maps. Now, we've heard how Suite has helped NHS Fife to gain a detailed understanding of the land use on their estate, in particular their green space. But let's take a look at how a similar configuration of Suite can be used to help a council better understand land use on a site it's looking to develop. Before we dive into a demo, though, let's have a quick recap of what Suite is and how it fits into the ArcGIS system. Now, Suite for ArcGIS is a web editing experience toolkit for data collection with built-in configurable data quality checks, helping users to edit data accurately the first time, every time. Now, Suite allows users to create, edit, and explore spatial data in the browser or across laptop and tablet devices, whether out in the field or in the office. Now, Suite is fully integrated with the ArcGIS system, meaning everyone benefits from using the same secure data for better informed decision making. So let's now take a look how, as an end user, I can make use of Suite's configurable and streamlined workflows to map out a green space in my area of interest. So I think we can all agree it's been a pretty wet summer this year, even by Scotland standards. And as a result, a local council is looking at areas of their estate where they can improve drainage and build upon existing water retention structures already in place. Now, this area in Glenrothes, Central Fife, has been identified as an area where additional drainage and water retention ponds can be developed. Before work starts on the construction of this new pond, however, the council wants to assess the existing land use in the area and ensure that the proposed pond location is suitable. So first of all, I'm going to want to create a site boundary of my study area to determine what the makeup of the land use is. If I turn on the survey area layer in my layer list, that's the wrong one, you can see that we already have a survey area for the site. Now, I could make use of the draw and follow function to trace around the outline of my site boundary, or I could make use of Suite's copy and paste function. Now, if you're familiar with copying and pasting records from one feature layer to another in ArcGIS Pro, this tool works in the exact same way. So first of all, I'm going to select the study area I'm interested in, head to copy, and then to paste, ensuring I'm pasting into my correct layer, in this case, my study area layer. I hit paste, and in the background, Suite will run a trigger, which will run an arcade script to generate a land use layer with pre-configured attributes derived from the underlying master map data I've added to my application. Now, we'll go into more detail about exactly how this works in just a second, but first of all, let's take a look at the layer I've just created. So if I start to interrogate this data, we can see I've started to classify areas of grassland, of water, and even man-made structures such as roads and buildings. So let's now take a look behind the scenes at how we can configure some of the tools and functions that I've just shown you in Suite. So here we are in the Suite builder, specifically the wireframe editor, and from within here I can configure the look and feel of my application, as well as turn on some of the out-of-the-box tools and functionality that come with Suite. So if you remember when I mentioned how we could have traced around the outline of my site boundary using the follow tool, I can quickly configure that in here by clicking on draw and enabling follow mode. And now this will follow any feature I have turned on in my layers list. Similarly, the copy and paste function I demonstrated can be turned on in the settings for the undo, redo, copy and paste tool settings. So it's important to note that these tools don't require any additional custom configuration and can be enabled and disabled from right here within the Suite builder. Let's now take a look at some data editor rules. Now, from within here, I can configure data topology and connectivity rules to layers within my application. So first of all, let's take a look at some topology rules. Now, topology rules allow you to define those relationships between features in a single feature class, such as here, where I'm saying that we can define it whether our polygon layers can overlap or contain holes. Now, in the case of our site boundary layer, we don't want our site boundary to contain any holes, but we do want features to be multi-part if the site demands it. For example, if my study area straddles a road, but the road itself isn't part of that study area. Now, topology rules can also define relationships between two feature classes, such as here, where we're saying our state land use layer must be contained within the site boundary defined polygons. Let's now take a look at some data rules. So if you remember our script that ran during the demo, creating our land use polygons, the trigger for that script occurs when we add a new row to our site boundary layer. So when we either drew our site boundary or copy and pasted in our boundary from the survey area layer, it set the script in motion. For our data changes, we want to add new records to our land use layer, and if I open up the script, we can see what's going on in the background. Now, I've marked this into 3 sections so you can follow along with me as I walk you through it. So in block 1, as I mentioned earlier, we have an underlying OS master map layer in our application. What our arcade script does here is it pulls through underlying features from our OS master map data before filtering out only those natural features as defined in the layers attribute table. In block 2, our script then decodes this information in the OS master map layer and applies our predetermined land use classification types to the data in its place. And then finally, in block 3, our script then copies the geometry and populates it with our newly defined attributes, returning new records in our land use feature layer. Now, I think we can all agree this is a pretty complex process, but it's all been achieved using a fairly small arcade script. Now, if arcade does seem a bit daunting to you, our editor does include examples, but more information can be found on our developer website and in the arcade playground. So now that we've classified our land use layer based on the underlying OS master map data, let's take a look at where the council is proposing to build its new drainage pond. So in my layer list, I've just turned on the proposed pond location which was provided to us by our planning team. Now, from first glances, it looks like the proposed area for a drainage pond looks feasible. It's situated in an area that's been classified as amenity grassland, so this could be a good location to build our new pond. There are a couple of other resources, though, we can call on, though, just to verify the accuracy of our land use layer. So I'm going to go to my layers list again, but this time I'm going to add a layer. Now, I can navigate my personal content and my organization and add this content to my app as a reference layer, but in this instance, I'm interested in the Living Atlas. Now, through the Living Atlas, we have access to hundreds of curated data sets that you can use as part of your applications and workflows. In this case, I'm interested in satellite-derived land classification data, so I'm going to search for Sentinel-2. So as you can see here, I have access to the European Space Agency World Cover 2020 Land Cover Image Service. Now, this might be a few years old, but should still give us a reasonable indication of whether or not our script has classified the land use data correctly. So if I adjust the transparency of our land use layer, you can see there's an area of dark green running across the area where our proposed drainage pond is due to sit. Now, I know that in the World Land Cover map, this dark green corresponds to an area of tree cover, which isn't what our script derived from the underlying OS master map data. So it's all very well deriving land use from a desk, but I think in order to verify this information, we're going to have to ground truth it, and how better to ground truth it than in the field with ArcGIS field maps. I'm now going to hand you over to Amy, who will walk you through the next part of our demo.
Thanks, Dan, that was sweet. So Daniel has just shown us how the planning team have used Suite for ArcGIS to inform decision-making when it comes to the site of a new water retention pond in Fife. In my role at the council, I'm required to be out on site and ground truth whether proposed developments like this are in fact feasible. As Catherine mentioned earlier, this on-site validation process is a fantastic use case for ArcGIS field maps. Daniel sent me a link to the proposed retention pond so that I could go and take a look. The URL that was sent to me was customized so that the field maps application opened onto this specific site with some of the information about this feature already filled in. Sending a custom URL like this ensures not only that the correct person is ground truthing the correct feature, but also helps to ensure consistency with regards to attribute information, such as feature names and descriptions. The other fields in the form created for this feature were left blank for me to fill in. Out on site, I could see that the land use map that had been used to select this site must have been incorrect, and the grassland where the new site had been placed was actually an area of woodland, and as such was not appropriate. The next questions have been configured to be conditional on whether this site is said to be suitable or not. When I select no, I'm required to say why the site is not suitable. This question had a list of options for which I selected incorrect land use type. I also wanted to take a picture of this woodland for the planners, and I was able to do this directly from the form and add this as an attachment to the feature. This attribute information provided in the form is now stored within the layer and can be viewed by anybody using it within ArcGIS Online once submitted. I then wanted to correct this land use layer and change the land use type from grassland to woodland to update this layer for the planning team. The land use layer has been made editable so that a user can update features but not add them. The form has been configured so that only the land use attribute can be edited. Once I submit this correction, this would have again also updated the layer for the team back in the office. Out on site, I then want to suggest a more appropriate location for the new retention pond. Rather than drawing the location, I did this using streaming. Using streaming, I was able to capture my location whilst walking a site perimeter, adding a new data point every few meters. For this data capture, I used a separate reference layer that was editable with the ability to not only update features, but also add new ones. As you can see, a geofence was configured on the reference layer so that alert is triggered if within 30 meters of another water feature. When I went within that distance, the alert warned me of this to ensure a suitable distance is maintained between the new feature and existing retention ponds. Once I completed the perimeter of the site, which you may have just noticed we completed by manually drawing it, as even we're not committed enough to battle through brambles for the purpose of a demo, I simply entered the required information in the form and submitted this as a new feature for the planners to review. We'll be showing in a minute when I pass back to Daniel how this newly drawn layer can be brought back into that suite application. So overall, I've shown how 3 separate layers have been used in field maps for different tasks and have been made editable in different ways. Now that you've seen the validation process in action out on site, I'll be showing some of the key elements of how this has been configured. The Field Maps Designer allows you to customize your maps for deploying in the field. It works with a simple drag and drop operation for configuring the form that field workers can edit when out collecting data. Here we can see the form for the land use layer that only had one element to edit, which was the land use type. You can add form elements from existing fields in the dataset, or you can add new form elements which will then be added as fields. Moving to the form for the new site layer, the layer with the proposed retention pond, we can take a look at how questions can be configured to be required or optional, editable or read-only, or visible or hidden, and how this can be dependent on the answer to a previous question, as we've seen. For example, the question about whether the site was suitable or not has been made always editable, always required, and always visible. Then, arcade expressions have been used to configure which questions appear once yes or no is selected to this. For example, the question for why the site is not suitable is always editable, not required, and has been made conditionally visible based on the expression. If I go to edit this expression, we can go into the expression builder and see how conditioning this visibility is really simple. All I've had to do is define the field that the visibility is based on, which is whether the site is suitable or not, and the condition, which in this case is no. Expressions can be made more complicated using the arcade editor. Once the form is set up and saved, we can move to the next tab, which is for configuring geofences. Arcade expressions can also now be used here, allowing for attribute-defined geofences. In this case, the land use layer defining the geofence was filtered so that only water features were incorporated in this. A 30-meter buffer was set around water features, and the message set so that on entry to this buffer, the user is alerted. Using arcade expressions with geofences is currently only available in ArcGIS Online, but is coming to ArcGIS Enterprise in a future update. It's also worth noting that to use geofences out in the field worker must have a license for location sharing. This is included in the mobile worker user type and is available as an add-on with all other user types. Moving through the configuration, I also want to highlight a tip in the App Settings tab. I use streaming when out in the field to draw the perimeter of the new site pond. You can alter the distance for which new points are added here. You could also change this to be a time so that data points are added en route after, say, 1 minute. In terms of altering how layers can be edited, as in whether features can be updated or added or deleted, this can be controlled from the Items Details page in ArcGIS Online. So we are now looking at the layer settings in ArcGIS Online for the reference layer, the layer on which the new pond location was drawn using streaming. All of these editing actions are allowed as reflected here in the settings. However, when I switch to the new site layer, the layer detailing the planned pond and which I was initially ground truthing, we can see here in the settings that this layer has been controlled, so that editing is enabled, but only for updating attributes. Features can't be added or deleted, and the geometry cannot be edited either. Altering these settings enables control over what field workers can or cannot edit, and also enables the use of layers for various purposes, as we've shown. Finally, I'll come back to the Field Maps Designer and go to the Sharing tab. The URL here is the one that we edited to make the map open on that proposed pond site with some of the form partly filled in. And I'm just going to briefly talk you through how this was done. It may look a little complicated, but once you have the structure, and there are plenty of example URL parameters online in the field maps documentation, all you need to do is add your own information. So this top one in black is that original URL from that share tab, and the one below is the one we've edited. The section in orange references the web map ID and the source of the layer to ensure that it's that layer that is opened upon. The purple section is identifying the specific feature using the global ID, and the final part in blue is defining the attribute and the information to be entered for that. We've also at Esri UK just released a blog regarding URL parameters, so if you're interested in taking a look into this a bit further, that would be a good one to look at in our resource centre on our website. So that was an overview of using ArcGIS field maps for ground truthing on site. I'm now going to hand back to Daniel to show what happened back in the office once we'd done that validation of the proposed retention pond.
Thank you for that, Amy. So now we've seen how ArcGIS field maps can make use of data created in Suite. Let's see how we can bring data collected in field maps back into Suite. So first of all, you'll notice that the area of amenity grassland that we'd incorrectly identified earlier has been updated. I can also see that the new site layer has been updated with information populated out in the field. Now I've already added in my reference layer captured in field maps, but as you can see it's not exactly pond shaped. So how can we then within Suite add this to our land use layer to incorporate it into a dashboard or web app for our ecologists to carry out their biodiversity net gain calculations, for example. So if I click on create and go to draw mode again, you'll see we have an option called stencils. Now there are a number of pre-configured stencils available to us, but to be honest, I don't think the planning or ecology teams are going to be over the moon if I use a dinosaur to represent my pond shape. So the other option then is to create my own using existing features within the app. So here's an outline of a pre-designed pond I created earlier, which I'm going to bring into my map and adjust roughly within my reference there. Now, while this newly created feature isn't likely to be used in the actual design of a pond, it is useful for teams and planners to determine land use post-construction. Now, part of the reason we're using a reference layer and adding this pond from our land use layer in Suite and not field maps is to maintain those topology rules between feature classes we set up in the builder earlier and ensuring that data quality. And just like that, we have a new drainage pond on our site. So just to recap, using Suite, we've created a land classification layer using some arcade. We've used Sentinel-2 data, courtesy of the Living Atlas, to verify our land use classifications from desktop. We then used field maps to ground truth this data, and using its configurable form designer, we were able to maintain data quality and integrity established by Suite. We then captured a potential new site location before bringing this information back into our Suite application and finalizing our designs for the new site. And with that, that concludes our demo. Thank you very much.